So you guys have asked for it, I'm going to be delivering it today. This is my full step-by-step guide to building a PC in the NZXT H6 Flow. So in my video that I released recently on best cases of 2023, this case was missing. A number of you pointed that out, but I only included cases in that video that I had actually built in 2023. So we're going to be putting that right at the start of 2024, doing a build in the case, and make sure you stick to the end of the video where I'm going to be sharing my thoughts on the case and seeing should I have actually included this in my best cases of 2023. Okay, taking a look at the other parts I'm going to be building with today. For the motherboard, I'm going to be using the ASUS ROG STRIX Z790 eGaming Wi-Fi 2. For the CPU, I'm using Intel's i9, the 14900K. Keeping our CPU cool, I've got a 360mm IO from ENERMAX, it's their LIQMAXFLO. For RAM, I've got 32GB of Kingston Fury Beast A-RGB DDR5 at 5600 megatransfers per second. For storage, I'm going with a single Gen 4 NVMe drive from Samsung. It's their 990 Pro in 2TB capacity. Powering the whole build, I've got an 850W fully modular ATX 3.0 power supply from Cooler Master. It's their GX3 850 Gold. For the graphics card, I'm going to be using the ASUS ROG STRIX RTX 4080. For case fans, I'm going to be using a mixture of ASUS's ROG STRIX XF120 and BQuat's Silent Wings 4 fans. Okay, that's all the parts. Let's make a start by taking a detailed look at the case. To remove our case's tempered glass panel, we've got a captive thumb screw at the back which we need to loosen. Once it's been loosened, the panel can simply be pulled out from the back and lifted up and away. Our other side panel is removed in the same way. There's a captive thumb screw at the back we need to loosen. Then we can push the panel out and lift up and away. Taking a look at the back of the panel we just removed, you'll notice we've got this area of perforations in it, and this is to provide intake for our power supply. There's no additional dust filters, and NZXT are just going with mesh on the side of the case. To remove our top panel, it's just a simple matter of lifting it up. Again, if we take a look at the panel we just removed, you'll notice there's no additional dust filters and we've just got mesh at the top. Take a look at the front of the case, we've got a standard tempered glass panel on the front, but bringing us onto the case's standout feature, and this is this angled mesh panel on the side of the case. So this mesh panel is removable, it's just a simple matter of pulling it off. Again, no dust filters behind the panel. And you can see that NZXT have installed three 120mm fans on the side of the case. So this is the standard version of the H6 Flow, which comes with non-RGB fans. If you get the RGB version, the three fans on the side will have RGB on them. And you can see the advantage of these fans. They're going to be providing lots of airflow in from the side of the case, but you're still going to have the tempered glass panel on the front of the case, giving you a great look into your build. Taking a look at our front I/O, we've got a power button, we've got two USB Type A, a single Type C, and a combined headphone and microphone jack. You shouldn't really need to remove the tempered glass panel at the front of the case, because you're going to have pretty good access to the case from the side, but for completeness I will show you how to remove it. To remove the tempered glass side panel, there's 5 screws we're going to have to remove. There's 3 screws on the top of the case, 1 screw on the side, and then we've got 1 screw on the inside of the case. So with all the screws removed, we're now able to lift the panel up and remove it from the side. So in terms of rigidity, it's probably not the best idea. You can see the case is a little bit mobile, and I would worry if you were to put pressure on it, you might actually bend it. So I am going to leave the panel out because it's going to give me better angles when I'm doing the build guide. But if you're building in the case, I would probably recommend just leaving this panel in place. So the case does come with these three 120mm fans pre-installed at the side, set to intake, and that's really all you're going to be able to mount at the side. There's no support for radiators at the side or 140mm fan support at the side. Up at the top of the case, you can mount up to 3 120 or 2 140mm fans, or up to a 360 or 280mm radiator. At the rear of the case, it's up to a 120mm fan or radiator. While at the bottom of the case you can see we've got this recessed area, and in here you're going to be able to mount up to 2 140mm fans. And you can see the fans are going to mount directly to the mesh panel on the bottom of the case. You can see we've got some little rubber mounts here for mounting 140mm fans, but a strange decision is that there's no actual holes for 120mm fans, so you are going to be limited to 2 140mm fans at the bottom of the case. And again, there's no separate dust filters, we've just got mesh on the bottom of the case. In terms of motherboard support, it's up to ATX in size, and you want to go with the CPR killer. The maximum height supported is 163mm. You can see at the rear of the case we've got 7 horizontal PCI expansion slot brackets, and in terms of graphics card support, the maximum length supported is 365mm. Moving into our second compartment, and our power supply is going to go at the top here. There's a little bracket for it to rest in, and the case is compatible with full-sized ATX power supplies up to a maximum length of 200mm. In terms of cable routing space, it doesn't look like we're going to have any problems here. We've got up to 91mm of space for routing our cables, and great to see we've got loads of Velcro cable straps here for managing our cables. Down below our power supply, we've got this hard drive cage. It's held on with a captive thumb screw here. And once it's been loosened, we're going to be able to lift the drive cage up to remove it from the case. So in the hard drive cage, we get our case accessory box. We'll go ahead and open that up. And in here, we've got absolutely loads of cable ties, and we've got all our screws individually packaged. I don't often install SATA drives in my builds, but if I did, I would absolutely love this hard drive cage. I think the design is absolutely brilliant. It's going to accommodate up to two 2.5-inch drives or one 3.5-inch drive, and the mechanism for mounting them is absolutely brilliant. It's just a simple matter of slotting your drives into the hole at the top for your 2.5-inch drives. And you'll see here, they're going to line up with some screws here. We're going to be able to secure our drives into place. In terms of mounting 3.5-inch drives, it's just a matter of sliding them in from the side. And you see that's then going to line up with the holes on the side. You're going to put screws into here and the same on the other side to secure your drive into place. In terms of our case cables, everything looks pretty good here. We've got our HD audio to let the combined headphone and microphone jack in the front of the case work. Our front panel connectors are all organised into one cable, which is going to make plugging them in so much easier. We've got our USB 3.0 cable to let the two Type A ports in the front of the case work, and our Type C cable as well. If we take a look at our case fans, it's great to see that NZXT have combined them all with a triple splitter cable, so there's only going to be this one connector to plug into a fan header and a motherboard to be able to control all three of the fans. If we do take a closer look at the triple splitter cable, you'll notice that while the triple splitter cable has 4-pin connections on it, our fans themselves are actually voltage controlled fans with 3-pin connectors on them. So what is important is whenever we're installing this, nothing different to do, but when we're setting up the fan control in the motherboard BIOS, we run the fans in DC mode. Because we run them in PWM mode, they'll run at 100% speed all of the time. We're going to be installing our CPU, the bracket for our CPU cooler, our M.2 SSD and our RAM before we put the motherboard into the case. To open our CPU socket, we're going to have to push this lever down and out to bring it all the way to the top of the motherboard, and then we're going to be able to open the socket cover up. We're then going to be able to lower our CPU down into the socket, making sure we've got the text the correct way up, and once we're happy it's sitting correctly in the socket, we can go ahead and close the socket cover. Now, I normally find with Intel boards it's easier to get the black bit of plastic to pop up now by just pushing down on this lever, and we'll pop it into the motherboard box for safekeeping. Then all we need to do is close the lever down again to secure the CPU. So our motherboard has 5 M.2 slots behind these heatsinks. The top one with a really beefy heatsink on it is a Gen 5 slot, and if we install our drive in here, it will run at Gen 5 speeds provided we've got a Gen 5 drive. But the downside of doing this is it shares PCIe lanes with our top PCIe slot. So without a drive installed here, this top slot will run in by 16 mode. If you install a drive in this slot, it will go downgrade to by 8 mode. That's fine if you do want to get the benefits of Gen 5 speeds and you've got a Gen 5 drive. We don't, we've got a Gen 4 drive. It's a nice fast Gen 4 drive, so we'd be better installing it in one of the other slots. So although all the bottom 4 drives are Gen 4x4 slots, the bottom left one, the PCIe lanes come directly from the CPU, while the other 3 go via the chipset. So this is the one we're going to want to install our drive in. The heatsink is held on with 2 screws. And then we can take our drive and slide it into the slot. We can go ahead and flatten the drive down. And then we're going to use this little clip here to hold the drive in place. If you're using the motherboard from new, there's going to be some plastic protection on the back of the heatsink that you're going to need to remove. And then it's just a simple matter of returning the heatsink. We're going to be installing our RAM in the 2nd and 4th slot along from the CPU, so I'm going to go ahead and open the clips on these slots. Then we can take our RAM, lining it up with the slot, and once we're happy everything's lined up, it's just some firm pressure and it's going to clip into place. Same thing with our 2nd stick of RAM, line it up with the slot, and again once we're happy it's lined up, some firm pressure, and it's going to clip into place. So because we've got an LGA 1700 motherboard, we're going to need the Intel backplate and the little bag of screws labelled Intel LGA 1700. And what we're going to do, we're going to take the backplate with the Intel side up and we're going to pop these screws through the middle hole in the bracket. Then we turn our backplate over and then we can take one of these little plastic spacers and push them onto each corner. Then all we need to do is line the bracket up with the back of our motherboard and it should fall through the holes. Then we just need to put one of these plastic spacers onto each corner. Then we can set the motherboard into the case, line it up with the standoffs at the back. So you'll notice that the middle standoff actually goes through the center hole in the motherboard, holding it in place. So we're not actually going to put a screw into this standoff, and we're going to use 8 of the motherboard screws to secure the motherboard to the case. Next thing to do is get our case cables plugged in, and our HD audio cable is going to go into this header on the bottom left hand side of the motherboard. So we can bring it through the cutout at the bottom, and we're going to plug it in with the HD audio text facing up the way. And then we'll just pull the excess cable through to the back. We've got a system fan header down at the bottom of the motherboard, so I'm going to bring the cable coming from our pre-installed case fans through, line it up with the header, push into place, and then we'll pull the excess cable through to the back. Our front panel connectors are going to go into this header here at the bottom right hand side of the motherboard. So we can go ahead and bring our cable through, and we're going to plug it in with the front panel text facing up the way. And again, we'll just pull all the excess cable through to the back. Our USB 3.0 cable is going to go into this header here, so we'll bring the cable through the cutout, line it up with the header, and push into place. And then just above that, we've got our front panel Type-C header, so we'll bring our cable through, line it up with the header, and push into place. And again, we'll just pull the excess cable through to the back. I'm going to install our case fans next, so I'm just going to pass the cable from our fans through to the back, and then lower the fans into place at the bottom. And you'll notice I'm having them set to intake. And then we're going to use 8 of the long fan screws that come with the case to secure the fans to the case. We've got 2 additional system fan headers down at the bottom of the case. So I've just brought the cables from the fans back through, and we're going to get them plugged into the headers at the bottom of the motherboard. And again, we'll just pull all the excess cable through to the back. We can set our 120mm fan into place at the back, and then we can use 4 of the shorter fan screws that come with the case to secure the fan to the case. We've got 2 system fan headers just here, so I'm going to plug the cable coming from the fan into one of them. And then I'm just going to route the cable around the top M.2 slot, and then we'll just tuck it in at the side of the fan. And you'll notice up top, just above where our motherboard goes, we have a little clip here to help organize the fan cable. So our power supply is fully modular, coming without any of the cables plugged in. I've gone ahead and plugged the cables in that we're going to need. So we've got a 12-volt high power cable to power our graphics card. We've got 2 8-pin EPS cables to provide additional power to our CPU, and we've got our 24-pin motherboard cable. So just before you install your power supply, if you haven't installed the backplate for your CPU cooler, you're going to need to do it before installing your power supply, because your power supply is going to block your access to this. And again, in the future, if you want to change your CPU cooler out, you may have to uninstall your power supply to get access to the back of the motherboard. So we can go ahead and set our power supply up into place and slide it all the way to the back of the case. And importantly, we're going to want to make sure our power supply's intake fan is facing out the way. Then we can use 4 of the power supply screws that come with the case to secure the power supply to the case. You'll notice on the back of the case we've got some cable tie down points, and the idea behind these, you're going to be able to use the included cable ties to manage the cables coming from the back of your power supply and also from your motherboard. Our 2 8-pin EPS cables are going to go into these headers at the top left of the motherboard. So we can go ahead and bring our cables through the cutout, line them up with the headers, and push into place. And then we'll just pull the excess cable through to the back. Our 24-pin cable is going to go into this header here, so we'll bring the cable through the cutout, line it up with the header, and push into place. And again, pull the excess cable through to the back. We're now ready to start working on our IO, and the first thing to do is set our fans onto the radiator. We're then going to use the long radiator screws that come with the IO to secure the fans to the radiator. Now, importantly, when you are setting the fans onto the radiator, you're going to have the end with the cables coming out towards the back of the case. And all we're going to do is daisy chain the fans together. They've got this proprietary connector on them. So it's just a matter of lining them up and pushing into place. So this one connector is going to allow us to control both the lighting and the speed of the fans. And we get this cable with multiple connectors on it, included with the IO in the box. And we're just going to go ahead and plug it in to the spare connector here. So on the ends of this cable, we're going to have 2 very familiar connectors. We've got a 4-pin PWM connector, which we're going to plug into our CPU fan header, allowing us to control the speed of the fans. And we've got a 3-pin 5-volt A-RGB connector, which is going to allow us to control the lighting effects on the fans. Both of the A-RGB and the PWM connectors have additional connectors coming from them. So this A-RGB one, we can pull this protective cover off, and we've got an additional 3-pin 5V A-RGB header. And in terms of our PWM connector, we've got a spare connector here, and these are for our pump. So coming from our pump, we've got two cables. The first is a 3-pin 5V A-RGB cable, and we're going to be able to plug that into that additional header on that cable coming from our fans, and that's going to allow us to control the lighting effects on the pump. Again, this cable has an additional A-RGB header on it, so if you did have another device and didn't have enough A-RGB headers on your motherboard, you are going to be able to plug something else into here. The other cable is a standard 4-pin PWM connector, and that is going to allow us to power the pump and control the pump speed. And if we take a closer look at our pump, you'll notice it has a built-in fan. I can remove this cover here, and you'll see they've got a fan here, and the same PWM cable that is going to control the pump is going to allow us to control this fan, and this fan is designed to help cool our VRM. This little cover is rotatable, so you can put it whatever way you need, and it will simply just slot into place. So you're going to have the ENERMAX logo up the right way, no matter which way you install this. Next, we're going to need to install the bracket to our pump, which is going to allow us to secure it to the motherboard. Because I've got an Intel motherboard, I'm going to be using the Intel bracket. There's a separate one for AMD in the box for the IO. And all you're going to do is line it up and push it into place. And you can see our AIO has got thermal paste pre-applied, so when we're ready to install it, all we're going to need to have to do is remove the plastic protection. So I think once we've installed our AIO, the top access to the port to the top of the motherboard is going to be limited. So for me, it makes sense to plug the cable into our CPU fan header and an A-RGB header at the top of the motherboard before we install the radiator. So I'm just going to bring the PWM cable through. This is our CPU fan header, and I'm going to get it plugged in to it. I'm also going to bring our A-RGB cable through, and then we'll just make sure we pull all the excess cable through to the back. Next, we can set our IO into place at the top of the case. So I am struggling a wee bit just to get this lined up at the top. It seems to be catching on the motherboard's IO shield at the back, and I just can't seem to get all the holes to line up. So I think what I'm going to do is I'm going to put a few of these screws in. So you'll see I have managed actually to get all these screws put in. It was the ones over at this side because this is where the radiator is pushing up against the motherboard. But as I worked my way along, I was able to get a few extra ones in. It did pull the radiator in a little bit. But one side issue here is the fans are resting with a bit of pressure up against our motherboard's IO shield. So fine for a temporary build for today, but it wouldn't be something I would want to leave long term. So I think the reason I'm getting into trouble in this case is this radiator is really thick. It is 38mm thick, and NZXT recommend keeping your radiator less than 30mm. So if this had been moved up by 8mm, it hopefully would clear the IO shield. So when you're picking your IO out from this case, just be really careful with the dimensions to make sure you're not going to have any problems mounting it at the top of the case. Just before we install our IO, there's some plastic protection on the bottom we're going to need to remove. So I'm going to be installing the IO with the tubes over to the right hand side. So I'm just going to take these cables and just route them around the top bracket, which is going to help organize them coming up to the top and making sure they're not getting caught on the cold plate, which they're not. And then it's just a matter of lining the bracket up with the one we've already installed on the motherboard. And then we're going to want to get a thumb screw onto each corner. Okay, now we've got a thumb screw in each corner. It's just a matter of tightening each corner up in turn. Next, I'm just going to pass the cables coming from our pump through to the back of the case. We've got some plastic protection on the IO to remove. And then we can replace the pump cover. To help organise the tubes coming from the IO, we get these little clips that come with the IO in the box, and it's just a matter of popping them over each tube. Now, I'm not going to use these. I think the tubes are actually sitting quite nicely, and the problem is when you put these on and off, they actually cause fraying of the tubes themselves. Not a big problem if you're doing one build, but if you're building with the same IO multiple times like I do, I just don't want to damage them. Then we just need to get our cables plugged in. So we've got the cable coming from the fans and the radiator, and we're just going to plug that into our multi-port cable that we've already plugged into our motherboard. Okay, that's those connected up. Next, we've got the PWM cable coming from our pump to plug into that PWM port on the multi-port cable. Okay, that's it connected up. The RGB cable coming from our pump to plug into the RGB port on the multi-port cable. So the multi-port cable we've already plugged into our motherboard, into a PWM header and an ARGB header. If your motherboard doesn't have an ARGB header, ENERMAX have got you covered. They include this little ARGB controller with the IO. This end plugs into a SATA cable coming from your power supply to power it. On this end here, we've got a 3-pin 5V A-RGB header, and that multi-port cable, rather than plugging into your motherboard, you simply plug into here, and you'll be able to press the buttons on the controller to adjust the A-RGB effects. We're now ready to install our graphics card, so we're going to need to move the second and third expansion slot cover from the top. So there's no actual button on this motherboard to open the clip on the top slot. Once we've installed our graphics card, we can press a button over here to move this clip and open it. But actually, when we just insert our graphics card into the slot, it will open automatically. If you have one of a different style of motherboard and there's a clip on it, just press it now to open it up. And then we can take our graphics card, line it up with the slot, and once we're happy everything's lined up, it's just some firm pressure to get it to go into place. Next, we can bring our 12-volt high power cable through, line it up with our graphics card, and push into place. Okay, last thing to do is some cable management and get the panels back on again. Okay, so that's the build complete and looking great. If you don't know how to install Windows or set the PC up, I have made another video covering all that, and I'll put a link to that video in the description. What I want to do now is take a look at the temperatures. So our i9 14900K idled at 34 degrees and reached a maximum of 99 degrees during the 10-minute ASUS stability test. During that test, there was up to 23% thermal throttling. Our RTX 4080 idled at 27 degrees and reached a maximum of 63 degrees during the stability test. In terms of noise levels, with all the fan curves running on the stock motherboard fan curves, we had average noise levels of 37 decibels at idle and 50 decibels under load. So in terms of those CPU temperatures, this is really what the 14900K does during a 10-minute ASUS stability test with stock settings. It just overheats no matter what cooler you put it on it, no matter what case you put it in. So it is a lovely CPU to use in your own system, but in terms of testing the thermals in each of the different cases, it doesn't really tell you an awful lot because it runs really hot and thermal throttles in every build I've put it in, no matter what cooler I use. GPU temperatures for this GPU are very good, and noise levels are a little bit noisier than what I would like. Most of that noise is coming from those DC fans that come pre-installed in the case, and because they are DC fans running with voltage control on the stock motherboard fan curves, which I use for the thermal testing, they run at a much higher rate than they would if they were PWM controlled fans. And actually, when I unplugged those three fans, the noise levels fell down by a whopping 5 decibels, down to 32 decibels, and you could barely hear any of the fans in this system. So I'm not planning on doing a separate case review. I'm saving those just for pre-release cases, but I will spend a few minutes here sharing my thoughts on the case. So in terms of building in the H6 Flow, there is a few important things to highlight here. I suppose the first is space at the top is quite limited. NZXT do recommend keeping your radiator less than 30mm in thickness, and I did install a 38mm thick radiator and did have some issues with the pressure on our motherboard I/O shield. So it is important when you're picking out your AIO that you're going to go with, be careful with those dimensions. NZXT don't give a combined radiator and fan, so I don't know with a standard thickness radiator, would you run into similar issues if you're using thick fans on it? And certainly like the Liandi Uni fans, some of those are 28mm thick rather than the standard 25mm thick, and would those extra 3mm cause issues as well? The other thing you might have with space is quite limited in this case, that you can fit an awful lot into a very small footprint on your desk. And in terms of cables at the top, I would recommend getting everything plugged in before installing your AIO at the top of the case. The other thing I did was actually remove the front tempered glass panel. And at the start, I actually recommended you probably shouldn't do this, but I think I would actually really struggled with this build had I not removed that panel. Getting the AIO in at the top would have been an absolute nightmare, particularly with that fan installed. I don't think I would have got it in. And the other thing, I think the graphics card might have been quite difficult to fit in as well. So I do actually think removing that front glass panel may give you some options if you're going with a big graphics card and a big AIO at the top of the case. The final thing to mention in terms of build experience, make sure you install your motherboard's backplate for your CPU cooler before you install your power supply. Because once you've installed your power supply, you're going to lose access to the back of the motherboard. So moving on to the things I liked about the case, and the first thing I liked about this case, I wasn't really expecting to like it, was the case's standout feature, that angled panel in between the front and the right side panel where your 3 fans are installed set to intake. Before actually getting the case to look at myself, I did think this was a little bit of a gimmick, but what it actually does is it hides the front fans. When you have your PC sitting on the desk and you're looking in from the front side, sort of on an angle, you can't actually see any of those fans at all. You get a lovely view of your build looking into that front and side panel, but you've also got the advantage of having good airflow coming in from those side intake fans. Also, because the fans aren't blowing at 90 degrees, there's a little bit of a 45-degree angle on them blowing air into the case. There should hopefully be less turbulence in the case and improved airflow in the case as well. I also really like the fact that this case is such a small footprint on your desk. You can fit an awful lot of hardware into it, up to 360mm AIO and a really large graphics card with no difficulty plugging in the 12-volt high power cable, albeit I did use a right angle connector on my one. In terms of cable management, it was absolutely brilliant at the back. You have loads of space and shouldn't have any difficulty managing all your cables, even if you do use cable extensions. And in terms of the price, for £100 for a case with 3 included case fans, and again, I don't think you need the RGB version on these fans because you're not actually going to see them. And the plain black ones, which is going to be a bit cheaper, is probably the version that I would go for. So moving on to the things I didn't like about the case, and probably the biggest disappointment for me is the 3 included case fans at the front having 3-pin connectors, meaning you're going to have to run them in DC mode, and in general the idle noise is going to be higher than if they were PWM fans. And again, it wouldn't have cost NZXT an awful lot more to supply 3 PWM fans. Some of the other things I'm a little bit disappointed in, again, it comes to the fan mounting options that you have. At the bottom of the case, there's no option at all for 120mm fans. It's 140mm fans or nothing. And really there was no reason at all why you couldn't have had extra holes at the bottom for 120mm fans. Again, I didn't experience this in my build because I had watched a few other build guides before actually putting this together, and some other reviewers did struggle when they used bigger fans like Lian Li's uni fans, and they weren't able to fit 2 140mm fans down at the bottom with Lian Li's uni fans, and they also struggled to fit 3 standard 120mm Lian Li uni fans on the side of the case. So again, some of the tolerances are really quite low. Again, I found this at the top with the AIO where I really struggled to get it fitted in at the top. So it is good that this is quite a compact case and a minimal footprint, but I think if some of the tolerances were just a little bit bigger, this case would have been so much better. I suppose a few other smaller points to mention. I did think it was great to have all the case screws individually packaged and labelled, but rather than labelling with the actual type of screw, it would have been much more useful to label with the function, i.e. power supply screws, motherboard screws, SSD screws, rather than the size of screw that you had, and then you had to go and refer to the manual to find out what you used that screw for. And again, a little box that kept all the screws in would have been more useful than the individual bags. Again, 2 other features that would have been nice to have seen in this case would have been a removable bracket at the top of the case and also a GPU support bracket. But again, given this case's budget price of only £100, I do think you are getting what you pay for. So in summary, I think definitely this case's positives outweigh any potential negatives. And if you do like the look of it and you are looking for a budget case, I can 100% recommend it. So hopefully you have enjoyed this full step-by-step PC build guide. If you have, please remember to give it a thumbs up. And if you're not currently subscribed to the channel, please hit that subscribe button as well. Thanks for watching.